All right, so next up, we'll be taking a look at the specific intermolecular forces. But before that, let's just clarify a couple things, right? So here we have two molecules, and we're talking about as an intermolecular force. It's some kind of attractive force, right? So it's something that's pulling these molecules together, right? Kind of how like, gravity pulls, an apple down from a tree. Some kind of attractive force is keeping these molecules together. And so then let's think about what these molecules and atoms are made out of. Remember that atoms are made out of protons in the nucleus that have a positive charge, and then electrons outside the nucleus that have a negative charge. There are also neutrons, of course, but they're not as important to this story. And then when we're talking about positive and negative charges, we know that opposites attract. So if we have something that's a positive charge and something that's a negative charge, there's going to be some type of attraction between the two. We're going to look at four main intermolecular forces. And most of them have to do with this attraction. Well, all of them have to do this attraction, right? The positive and the negatives are attracted to one another. And then one more way that we can show this kind of distribution of charge is through our dipoles, right? So whenever you see this kind of arrow, this indicates that there's some kind of separation of charge. On the one side of the arrow, we have the positive end. And then on the other side, we have the negative end. And then if we think about how two dipoles may interact with one another, remember that's opposites attract. So it would look something like this, right? Where the head of the arrow is going on to the plus sign of the arrow, because again, positive and negative charges attract. And so that's our attraction, and that'll be the basis of pretty much all of our intermolecular forces. It's going to be some kind of interaction between a positive and a negative charge.